The greenhouse effect is a natural warming process. Some sunlight that hits the Earth is reflected. Some is trapped by greenhouse gases in the atmosphere and becomes heat. The primary greenhouse gases are carbon dioxide, methane, and nitrous oxide. The global warming potential for each molecule of methane is 25 times the global warming potential of carbon dioxide. The global warming potential for each molecule of nitrous oxide is 298 times the global warming potential of carbon dioxide. The amount of greenhouse gases in the atmosphere is increasing rapidly, causing the Earth's climate change. West Systems produces a portable, high-resolution diffuse flux meter to meet the needs of scientists and engineers involved in determining the gas exchange in soil respiration and seepage from natural or artificial gas reservoirs. The flux meter is operated by a handheld computer that makes it possible to georeference acquired data. The methane detector is based on a tunable diode laser absorption spectroscope combined with a multi-pass cell. The carbon dioxide detector is based on absorption spectroscopy. The accumulation chamber procedure consists in the following steps for each sampling point. 1. Sealing the flux chamber to the ground surface. An effective seal between the accumulation chamber and the site surface will depend on soil characteristics. 2. Measuring the GHG concentrations in the chamber every second over a period of 2 to 3 minutes. The concentration versus time curves are fitted by applying a linear best fit to compute the concentration gradient. 3. Calculating the gas flux by multiplying the concentration gradient by the accumulation chamber constant, a factor proportional to the internal volume of the chamber divided by the accumulation chamber footprint area. The accumulation chamber method is not affected by environmental parameters such as soil porosity. The obtained measurement is the effective rate of emissions from the examined area. West Systems flux meter can measure methane fluxes from 0.0005 to 1000 moles per square meter per day and carbon dioxide fluxes from 0.002 to 300 moles per square meter per day. The measurements can be extended to VOC, or volatile organic compounds, nitrous oxide, and other gas species. The normal soil respiration in a rice paddy produces methane fluxes ranging between 0 to 0.01 moles per square meter per day and carbon dioxide fluxes ranging between 0.003 to 1 moles per square meter per day. La Bacanella represents a practical example of an anomalous degassing area. Let's measure diffuse emissions with West Systems portable flux meter in several points of this area. Let's seal the flux chamber to the ground surface. After that, let's take the measurement. GHG concentrations in the chamber are measured every second over a period of 2 to 3 minutes. The concentration versus time curves are fitted by applying a linear best fit to compute the concentration gradient. The results of the measurements show a concentration gradient of 0.89 ppm per second for carbon dioxide, yet there is no increase in concentration for methane and hydrogen sulfide. Let's compute the fluxes by multiplying the concentration gradient by the accumulation chamber constant. The results of the measurements show a flux of 0.3 moles per square meter per day for carbon dioxide and no fluxes for methane and hydrogen sulfide. These are the typical values of normal soil due to soil respiration. Let's repeat the measurement in another area, which shows marked anomalies following the same steps as before: sealing the chamber, measuring the gas concentration every second for 2 to 3 minutes. In this case, the measurement results show a concentration gradient of 160 ppm per second for carbon dioxide, 0.37 ppm per second for methane, and 0.036 ppm per second for hydrogen sulfide. For this sampling point, we observe a very high increase in carbon dioxide concentration and also an increase of methane and hydrogen sulfide concentrations. Computing these concentration gradients as before, we observe that for this sampling point, we have a carbon dioxide flux of 55 moles per square meter per day, a methane flux of 0.13 moles per square meter per day, and a hydrogen sulfide flux of 0.012 moles per square meter per day. These values represent a very important anomaly. These values tell us that every square meter of this area emits about 2.5 kilograms of carbon dioxide and 2 grams of methane. That is equivalent to about 50 grams of carbon dioxide every day. Let's repeat the measurement in another sampling point. Let's measure the fluxes in the middle of the anomalous area. The flux meter shows a concentration gradient of 487 ppm per second for carbon dioxide, 1.11 ppm per second for methane, and 0.34 ppm per second for hydrogen sulfide. This means a carbon dioxide flux of 170 moles per square meter per day, more than 170 times of a normal soil flux, a methane flux of 0.40 moles per square meter per day, more than 40 times of a rice paddy flux, and a hydrogen sulfide flux of 0.12 moles per square meter per day. A great anomaly. This site represents a very anomalous degassing area. All around this area, soil respiration is the same as for normal soil. On the edge of the circle, GHG emissions are 50 times more than for normal soil. Finally, in the middle of the area, GHG emissions are 150 times higher than for normal soil. The degassing anomaly can probably be connected to geothermal and/or paleovolcanic activity. WES systems flux meters are also used for volcanological surveillance, especially for carbon dioxide and hydrogen sulfide. The flux meter can be used in the same way to identify and characterize abnormal gas emissions due to anthropic activities. For example, WES systems flux meter is used for monitoring landfills for diffuse emissions according to the Azienda dell'Ambiente, environmental agency, on monitoring landfill gas surface emissions. It is used for agriculture, especially for carbon dioxide, methane, and nitrous oxide emissions. Furthermore, the flux meter can be used for measuring volatile organic compounds from contaminated sites.